Now, Newton's divided difference interpolating polynomial. Interpolating polynomial. See the derivation. What is that? Let x0 comma x1 dash dash xn be the set of n plus 1 data points, right? 0 to n means n plus 1 data points and f0, f1 and so on fn with the corresponding function values. One can write like this: f of x0, f of x1 and so on f of xn with the function values. Now let Pnx be the interpolating polynomial. Means what? Pnx is approximately equal to f of x. Pnx with the interpolating polynomial given by, assume this polynomial as Pnx is equal to a0 plus x minus x0 into a1 plus x minus x0 x minus x1 into a2 plus and so on, and the last term x minus x0 x minus x1 and so on x minus x n minus 1 an x n minus 1 an, equation 1, where a0, a1 and so on an are to be determined. These are the constants are to be determined. We have to find the values of these arbitrary constants to be determined. Now take x equal to x0, then what is 1 becomes if I put x equal to x0, what is this is left side is Pn of x0 equal to x x0 means this part 0, this part 0 and every term 0 except a0. So a0 value is over, finished. Next take x equal to x1, then 1 implies, take x equal to x1, then equation 1 implies Pn of x1, right, equal to a0 plus x1 minus x0 into a1, and remaining part what? X minus x1, where at x equal to x1 these terms are zeros. Okay, from this I can write what is this value. Okay, from this I write therefore a0 equal to what? F of x0. This is the main value, a0 equal to f of x0. Now let us write a1 value. What is a1 from this expression? This is a1 is equal to, isn't it, Pn of xn means what? F of x1 minus a0 by x1 minus x0. This a1 equal to, this value is what? F of x1 minus a0 by this one. And what is a0 value? F of x0. Therefore what is a1 becomes f of x1 minus f of x0 by x1 minus x0. And what is this value? In the first divide difference, x0 x1. Now at x equal to x2, equation 1 implies Pn of x2 equal to a0 plus x2 minus x0 a0 plus x2 minus x0 x2 minus x1 a1. Remaining all other terms will be 0. So what is this is? This is nothing but f of x2. a0 is nothing but f of x0, right? Okay, this is a1 and this is a2. F of x naught plus x2 minus x naught a1. What is a1? A1 is what? This expression, f of first divide difference plus x2 minus x naught x2 minus x1 into a2. From this I can write a2 as 1 by x2 minus x naught x2 minus x1. Okay, and this whole bracket f of x2 minus f of x naught minus x2 minus x naught first divide difference. What is this value? Is nothing but f of x1 minus f of x naught by x1 minus x naught, x1 minus x naught. This is entire. If I simplify this expression, then a2 becomes, starting with f of x naught. Okay, after simplification I will get f of x naught by x naught minus x1 x naught minus x2 plus f of x1 by x1 minus x naught x1 minus x2 plus f of x2 by x2 minus x naught x2 minus x1. And already we know that what is this expression? This right side expression is second divide difference, okay, and so on. So in general, what I am getting, an is not, in general one can write, in general an is what? Nth divide difference, x0 x1 and so on, xn. Okay, now substituting all these values in the expression 1. Now substitute a0 a1 and so on an in equation 1. So 1 becomes, what is the one expression? Pnx equal to, first one is what? F of x naught plus x minus x naught into a1 is nothing but what? First divide difference plus x minus x naught x minus x1 into a2 is nothing but what? Second divide difference, and so on. And lastly, what is the last term? Nth divide difference, x minus x naught x minus x1 and so on, x minus xn minus 1 an. What is an? Is nth divide difference, x1 x2 up to xn. This is equation 2, is called Newton's divided difference interpolating polynomial. Okay, this is the derivation of Newton's divide difference interpolating polynomial. One note, what is that? Since interpolating polynomial is unique, existence and unique, Lagrange and divided, Lagrange interpolation and divided difference polynomials, both polynomials are two different forms, both represents two different forms of the same polynomial. That means using both the formulae we will get same polynomial, even though the formula may be different, looks like different, but whatever the polynomial we will get, that is unique.